Can you put a variable frequency drive on any fan? No.
The useful question is whether the complete fan, motor, drive, and control system are compatible. A VFD can be an excellent tool, but only after the motor type, electrical limits, and mechanical operating range pass a documented compatibility review. A VFD first rectifies incoming AC to a DC link, then switches the DC into a pulse-width modulated output whose fundamental frequency and voltage are controlled.
The motor does not receive a perfectly smooth sine wave.
That distinction matters because frequency changes speed, while the fast voltage pulses also change insulation, cable, and bearing stresses.
Start by classifying the motor system. A conventional three-phase induction motor may be a candidate when the motor and drive manufacturers permit the pairing. A single-phase capacitor motor is a different circuit and must not be treated as a smaller three-phase motor. An EC fan already contains power electronics and must be evaluated as a complete assembly. Equipment with an existing controller needs the same boundary check.
The nameplate is the first gate, not the final answer. Record rated voltage, frequency, current, phase, speed, duty, insulation, and service factor where provided. Then obtain the exact motor and drive documentation. Do not assume that every three-phase motor is inverter duty, and do not invent a universal volts per hertz curve or minimum frequency. Next, examine the electrical path. Fast-rising drive pulses can increase motor terminal voltage stress, especially as cable behavior and installation details change. The selected combination may require a specified motor cable, grounding method, output reactor, DV/DT filter, or common mode filter. Those requirements come from the manufacturer's tables, not from a generic wiring picture. Low-speed cooling is a separate limit. A shaft-mounted motor fan also slows when the motor slows, even if the driven fan needs substantial torque.
The result can be adequate airflow at the process but inadequate cooling at the motor.
The real Longwell auxiliary cooling fan images show one hardware approach. They do not establish a universal minimum speed or prove that every installation needs that accessory. Bearing current and grounding deserve their own gate. High-frequency common mode voltage can create current paths through the shaft and bearings. Cable symmetry, shield termination, bonding, filters, and insulated bearings may be part of the documented solution. The correct remedy depends on drive size, motor construction, cable length, and installation, not on one rule copied across projects. The fan laws explain why speed control can save energy, but they are not a savings guarantee. Under comparable conditions, airflow varies approximately with speed, pressure with speed squared, and shaft power with speed cubed. The system curve, static pressure requirement, drive and motor losses, control strategy, and duty profile determine the measured result. Commission the actual operating points. Electrical compatibility is still not mechanical permission. Confirm the impeller's maximum safe speed, motor maximum frequency, balance condition, critical speeds, bearing limits, and any resonance bands in the installed structure. Overspeed can damage rotating parts, and apparently harmless intermediate speed can excite vibration. Define approved speed ranges and exclusion bands before operation. Now integrate controls and protection. Verify motor current data, overload model, acceleration and deceleration limits, minimum and maximum frequency, permissives, emergency behavior, sensor scaling, alarms, and fallback state. Never switch a contactor on the drive output unless the exact drive design permits the sequence. Bypass arrangements and line-side switching also require engineered interlocks. The Longwell YVF2 catalog supports a variable frequency three-phase motor family, while the real auxiliary cooling fan and EC fan images make the hardware categories visible. They do not authorize a project setting. In particular, an upstream VFD must never be assumed compatible with an EC fan's electronics. Use the complete assembly's approved control input and documentation. The decision is a gated checklist. Classify the motor and controller, match voltage and current, verify insulation and cable rules, proof cooling, review bearings and grounding, confirm the fan speed envelope, analyze resonance, define controls and protection, and commission the duty points. Before inspection or wiring, qualified personnel must de-energize, isolate, lock and tag, discharge stored energy, verify absence of voltage, and follow the exact project documents.